Hi everybody. So here's your practice, your applications of your exponential functions. If you review your growth and decay formula, is going to look like this. If they use the word continuous growth of decay, then we can go ahead and model it by using that formula with E. Remember, we only use E when we're talking about a continuous growth or decay situation. All right. So growth or decay, exponential real quick, looking like this. Continuous, looking like this. And make sure you remember your A is your initial amount, your growth rate, and your time. And we want to make sure you understand that concept of growth rate. So if they say it's increasing at 45%, you want to make sure that that is the decimal that you use. Decreasing by 10%, you want to make sure that you use that negative exponent of negative 0.1. And when we have that negative exponent, that's going to make that negative exponent into that fraction that we can know that that'll move that to the denominator. So if it's decreasing by 10%, that'll be a 1/10. And having that negative exponent will give you that value. Negative 0.40 and positive 200% is 2. So if you remember the rule about bouncing your decimal place 2 points, bouncing your decimal place 2 points, that can help you know how to convert those percents into decimals. Okay, so let's do some practice problems together. A new car that sells for $29,000 depreciates 12% each year. It doesn't say continuous, so we're not going to use E for this one. If it's not continuous, then that is going to be the formula that we want to make sure that we use. Okay, so a new car, my amount over time is going to be equal to that amount times 1 plus my rate, and that is going to be and to the T power, that's going to represent what we're talking about there. So here we have the amount of my car after 7 years, so we'll put that in there, is equal to that $29,000 that I started off with, and it's going to be depreciating, so I want to have minus 0.12. And if you think about it, that's going to mean that I'm calculating what is 88% of this value, and I'm going to do that, 7 times. Okay, so we'll go ahead and we'll talk about our calculator. And remember, you can use decimals on this also if you want to. So I want to know what $29,000 is if it's depreciating at 1 minus 12% for 7 years. Oh, look, I didn't have enough zeros in my answer. Let's try that again. A $29,000 car, we like that better. 1 minus 12% for 7 years. We like that better. Okay, so your $29,000 car after 7 years is only worth, get this, $11,851.59. So you lose a lot of money the minute you drive it off the lot, but after 7 years, it's lost over half its value. That's crazy. Okay, the price of a new home is that. The value of the home appreciates. So if we're appreciating, that's 2% per year. And I want to know what it's going to be worth in 10 years. So my amount in 10 years is going to be equal to my initial amount, which is my house was worth $350,000. And it's appreciating, so this is going to be a plus. And 2% is going to look like that for 10 years. So when I go ahead and I enter that into the calculator, I have the value of my home $350,000. And I'm going to be multiplying that times my rate of growth, which will be 1 plus my 2%, and that's going to happen 10 times. So at the end of 10 years, if the value of my house continues to grow, check out what my house is now worth. $426,000. It's pretty cool, right? Okay. The population of an endangered bird is decreasing. So we're going to make sure we know that's going to be a negative percent per year. There are currently 200,000 of these birds. What exponential would be a good model for the population of the birds? So the population over some time is going to be equal to the number of birds that I start off with times 1 minus 0.75. That's a lot of birds I'm losing for however many years. So now we're talking about 100 years. The amount of birds after 100 years is going to be equal to my 200,000 I started off with. And then as I lose my birds, and again, I'm talking about 100 years. Where do you see how much of these birds are gone? So there's 200,000, check my zeros again, times 1 minus 0.75. Ooh, check it out. It's 0.705%. I'm so relieved. I thought we were losing an awful lot of birds. So I move this decimal place 2 decimals, so that's 2 zeros, 75. We need to add 2 zeros in there. We like that better. I was going to say, we're losing 75% of our birds? No, 0.75% of those birds are going to be going away. At the end of 10 years, I will still have 94,206 birds. So we're going to have to go ahead and round up to 94,207 birds. Make sure you don't make that mistake. Be very careful with converting those decimals into, or those percents into decimals. All right. Our next one, the population of a city P is, here's this equation, where T is equal to 0, represents the population in year 2000. Find the population of the city in year 2010. So that means our T is going to equal to 10. So my population is equal to 250,342. And it looks like I have E, so there's continuous growth. And I have 0.012. And then my T is going to be times 10 years. So my population when T, we use this function notation. It makes it easier for us to remember what value we plugged in for our variable. So 342,000 times E to the, we'll use our parentheses, 0.012 times 10. And that's going to give us a population of 282,259.82. So when we talk about the population of the city is going to be about 282,000, and we'll say 260 people, since we'll go ahead and round up when we round. All right. Find the population of the city in 2015. Now we're going to have it where my T is equal to 15. So depending on what calculator you have, you can hit second entry. An entry is this button. It's the second function above your enter. See where it says entry? And you can have the calculator re-enter your equation for you. So by hitting second entry, it comes back in, and all I need to do here is change this 0 to a 5 so that it's going to be in 15 years. So my equation is P is equal to the population of my city as it stands now. Here's my continuous growth rate, and that's 0.012. That doesn't change, but what does change is that now I have a 15 instead of the 10. So just by changing that, I can see that my population is going to be equal to 299,700, and we'll call that 14 people. There you go. All right, let's check out the problems on the back. Okay, so we'll review again. Compound interest applications, interest earned is added to how much you start with. So this compound interest review, if interest is calculated in different time periods, you're going to use this, and this N is going to represent the number of times that you're calculating it. And then if it's continually compounded, we're going to use our PERT formula. So we go back to our two formulas, periodic and continuous, and we can see those two different stories and then what each of those variables represents. All right. If you find the accumulated value of a $500,000 investment for 8 years at 12%, that it is being compounded. Let's go ahead and take a look at that if we do it annually. Now here's a little chart to help you with the vocabulary. If it's annually, that means it's once a year. If it's semi-annually, twice a year, quarterly, 4 times a year, monthly, 12 times a year, bi-weekly is going to be 26 times a year, weekly 52 times a year, and daily. All right, so if I need to figure out my money when I'm doing it annually, that's 1 time a year. I know that my amount is equal to my principal, which is my $5,000. And I'm going to be increasing, so it's 1 plus, and my rate is going to be 12%, and I'm doing it 1 time, that's my annually, and I'm doing it for 8 years. So when I enter that into my calculator, I'm going to have my $5,000 that I started off with, and I'm going to be multiplying it by 1 plus my 0.12, and I don't have to divide by 1 because we know what that's worth, and I don't have to do this multiplication either because that'll be my money that I get after 8 years. So after 8 years, I wind up with $12,000. That's a great growth rate. $379, and we'll call that 82 cents. All right, so make a prediction right now. If I calculate it more times each, if I calculate it more times each year, am I going to be making more or less money than that? If you said more, you're on the right track. All right, semi-annually, which means I'm going to be doing it 2 times. All right, so my amount is equal to my $5,000 that I'm putting in, my 1 plus my 12%, but I'm going to be doing that divided by half because I'm going to be doing that calculation twice. So I'll do half now and half in 6 months. So my N is going to be 2 times that 8 time for 8 years. All right, so $5,000 times my 1 plus. Now I got to think about this carefully because it's 0.12 divided by 2. So I have to have that expression tucked inside of those parentheses and that whole thing to the 2 times 8 power. Check it out. If I do those calculations twice a year, I get about $400 more. I'd like $400 more. All right, so now we're going to talk about quarterly. If we go to the vocabulary chart, quarterly is equal to 4 times a year, which means my amount I get, that's the money I start off with. Here's my rate, but instead of doing the math once or twice a year, I'm going to be doing it 4 times a year. Now here's a calculator trick that can help save you time. If I do second and I hit entry, which is this blue function here, second entry, that repeats what I entered in last time. So now I can go up and change my number of times that I'm calculating my interest. That becomes a 4, and this too becomes a 4. Check out how much money I have now. $12,875.41. Now check that out. I gained about $350, and then here it looks like I only gained about $175. So your initial growth is huge, and then it begins to taper off. All right, let's take a look at what happens if I do this math monthly. So monthly means 12 times. So I'm going to do my amount is equal to my $5,000, 1 plus 0.12 over, and of course I'm going to put a 12 here and a 12 here and the 8 years that I do this math for. So again, let's look at how much more money I get. I can do second entry, and then instead of dividing by 4, I have to divide by 12. Now I might have to do second insert to give myself another space. And then I'm going to come down to this part, and this 4 is also going to become a 12, and I have to do second insert to give myself another space. So now my amount of money that I have is up to $12,996.36. So now I've only gone up about $100. So you can see I'm still increasing, but I'm, catch this, increasing at a decreasing rate. All right, now we're going to use our continuous formula. And this is going to be one that's really going to highlight that value of E, how that's our constant. So when we're doing something continuously, that's where I need E as my constant. So I'll jump to and use my PERT formula. So my amount is equal to my principal times E and my rate and time. So my amount is going to be equal to my $5,000. And instead of dealing with a rate here, I'm just going to trust that E is that constant. And then I'm going to raise E to the rate of how much money I'm making, which is 12%. And that'll be times how many years I'm doing it, which is 8 years. So let's go ahead and put that into the calculator. My $5,000 is going to be multiplied by E. That's my second and my division symbol. And then that is going to be raised to, and remember you need your parentheses, 0.12 times 8. So now if I do it continuously, this is how much money. This is the maximum I'm going to get. My amount is equal to $13,058.48. So notice that $5,000 investment, the more and more and more and more frequently I do the math, I end up with more money each time. Okay. Find the amount in a continuously compounded account for the given conditions. Again, it's continuous, so I know that my amount is equal to my principal, ERT, the PERT. So I know my amount is equal to my $5,000 and my times my E, which is my constant of continuously compounding, and my rate is 6.9%. So remember, we have to write that as a decimal, and that's going to be for 30 years. So when I get my calculator and I go to enter in this, I have my $5,000 investment, and that's going to be multiplied by E, and that E is going to be raised to the power of my rate times how many years we're doing this math. So check it out. After 30 years, you are going to have $39,624 and 12 cents if we round. $5,000 at 6.9% for 30 years. That's a pretty good investment, don't you think? All right, let's talk about our next one. You deposit $975 in an account. So you know, if we're talking about each of our factors, this is my P. And this is going to be my rate. And I'm going to have to write that as a decimal. So I'm going to bump that over 2 decimal places. And it's compounded continuously. So you know I'm going to use A is equal to PERT. What is the balance after 6 years? So my amount is equal to my $975 times E. And that's going to be times my rate, which is 0.055. For how many years was it? 6 years. So I have my $975, and it's going to be times my E, and that's going to be raised to the 0.055, 5.5% times how many years we're talking about. And by the end of that time, I'm going to have $1,356.19. First of all, look at the difference that the impact of having many more years and a higher interest rate make. Because it doesn't seem like that's enough growth, but yep, that's it. All right, let's check out number 4. You are given $1,000 on your 16th birthday. How much do we have in 60 years? Holy cow. You want to hold off pulling on that money for 60 years? And it looks like you invested at 8% interest. That's a pretty good interest rate, don't you think? All right. So if it's compounded yearly, we're going to use our first formula. So that means that my amount is equal to my principal plus, or times 1 plus my rate over n for how many n years we're doing. So my amount is equal to my principal, which is $1,000, times 1 plus my rate, which is going to be 8%, And I'm only doing it compounded yearly. And then so this n really is not even a factor, and I have 60 years. So let's go ahead and see what that's worth. 1,000 times 1 plus 0.08, and that's going to be to the 60th power. So by the end of that time, if you don't touch it for 60 years, you have $101,000, 257.06. All right, let's check it out with our compounding continuously. If we are compounding continuously, our amount is equal to PERT. So then my amount is going to be equal to, here's my $1,000. And we'll go ahead and say that's PERT times E. And that E is going to be to my rate, which is 0.08% times 60. Where you see what a difference this is. $1,000 times E to the parens 0.08 times 60. What would you rather have? $101,000 or $121,510.42. So make sure that when you are investing your money, you ask, are we compounding yearly or compounding continuously? Gives you a heck of a lot more money, doesn't it? All right, good job today. Go ahead and click over to the Google form so you can answer some questions for me.